let's keep moving. Same process. This is just extra practice, so try this on your own if you like, or you can watch, either way. Let's go ahead and factor, if it factors, and I believe it does, x plus 3, x plus 4, in the numerator. The denominator is x plus 4, x minus 3, and grab this faulty pencil here that keeps breaking. Mark those out. Cancel them out. X plus 3 over x minus 3. Because something canceled, that means we have holes in the graph. Well, a hole. There is a hole in, that didn't come out right. There is a hole in the graph. One singular hole. And that is where x plus 4 equals 0. So x equals negative 4. And so not only do I have a hole at x equals negative 4, I need to know what the y coordinate is. So if I was to plot this point, and I said, hey, where's the hole in the graph? There's a point, right? And you'd say, oh, it's at negative 4, and I would wait for you to tell me the next coordinate. So I need more. It's not just x equals negative 4. So it's going to be y equals something also. And what does y equal? Well, okay, y equals, skip it, go to the end. And then we're going to plug a negative 4 in right here. So negative 4 plus 3 over negative 4 minus 3, that gives me negative 1 over negative 7, so positive 1/7. So final answer, I have a hole in my graph at negative 4 comma positive 1/7. And so 1, 2, 3, 4, negative 4, positive 1/7, just up a little bit. There we go. There's a hole right there. Fantastic. Let's find the x-intercept. That is where y equals 0. So 0 equals, skip it, go to the end, x plus 3 over x minus 3. I hope you've noticed by now that denominator is going to just go away. 0 times that denominator, 1 times that numerator, and x equals negative 3. There we go. There is an x-intercept right there. All right, what's my y-intercept? Y-intercept is where x equals 0. This is the easy one. So y equals 0 plus 3 over 0 minus 3. That's equal to negative 1. So y equals negative 1. Sweet. Okay, let's find the ha. And I put HV. Horizontal asymptote that does not have a V in it. Horizontal. Can't get my whiteout to work either. And my aim was off. My goodness, it's a mess. All right, let me do the shortcut, and you can graph it if you want to see it, but here's the way it is. So here's what I do. This is illegal canceling, but it actually works when you're thinking of enormously large numbers or very, very negative numbers. The positive 3 and the negative 3, if I plugged in like a million, I'd have 1,000,003 divided by 1,000,000 minus 3, and I would basically have something super close to 1,000,000 divided by 1,000,000, so I could ignore those. This is the way I explain it in a lot of higher level classes, and I think you can handle it. So x over x is just 1, and it would be y equals 1. It's a horizontal line. Now, if that didn't make sense, you could graph this original function or that, and you would have the same looking graph with the exception of one coordinate, and y equals 1 would be where it levels off. Similar, this is not the same problem, but similar to the last problem where it leveled off at 1, okay? The vertical asymptote is where my denominator, not this guy, you factored him, and not this guy, you canceled him, but this guy is where my denominator equals 0, and so x equals 3. So horizontal asymptote here, this pencil lead breaks, I might throw it. The pencil and the pencil lead. X equals 3. I have a tantrum right there on camera. All right, so let's graph it. Now, I don't know what happens over here. I know it kind of does something like this. You can graph it on Desmos or a calculator to see what it does. But over here, you have this. There it goes, and it crosses that point, and goes through this, but doesn't go through it. Like, it doesn't actually touch.